how's everybody doing? All right, so this is the last of the naming notes. So up until this point, we have been dealing with putting metals and nonmetals together. We've been doing transitions and nonmetals. We've been doing metals in general with polyatomics. So it's always been a positive and a negative, a cation and a cation, a plus and a negative. We're going to learn something today that's a little bit different, where you're going to be putting two non-metals together, or two negative charges. And actually, the charges for this next set of naming and bonding, the charges don't even matter. Okay, so we're going to be dealing with molecular compounds. And a molecular compound, these are compounds composed of two or more nonmetals by a covalent bond. Okay, so up to this point, we've been dealing with ionic bonds, right? You have positive ions with negative ions, positive ions, negative ions. So you've been trying to figure out how many pluses and minuses you need in order to make the charges add up to zero, or for it to be neutral. Well, we are now dealing with a covalent bond, and a covalent bond does not deal with charges. It just does not deal with electrons coming together to create something that is neutral. Now what's happening in a covalent bond are the electrons are going to be shared. So we're going to delve into this a little bit more next unit and how this works. But for now, what I want you to know is that molecular compounds are compounds composed of two or more nonmetals. So over here, by a covalent bond. They are bonded together by a covalent bond, which is where electrons are shared. Where an ionic bond is a give or a take of ions, pluses and minuses. Okay, so this is relatively easy. I think it's a little bit easier than ionic bonding, but you do have to do a little bit of memorization. So step number one is to identify how many atoms of the first nonmetal are present. So if you take a look at this compound right here, we have SO2. How many sulfurs are in this compound? Well, there's one sulfur here, right? Because there's no subscript, so automatically we're going to assume that there's one. And how many oxygens are right here? Well, since there's a subscript of two oxygens, there is two. Now, a lot of you might want to look at this and say, oh, SO2, doesn't that resemble a polyatomic ion we have in here? Well, it does, but there is no polyatomic ion that is SO2. We have SO3 and SO4, okay? So it's not a polyatomic. And it also is not a polyatomic ion because there's no charge here. So this already is neutral. So what we need to do is we need to identify how many atoms of the first nonmetal are present. There's one sulfur. And then we need to write the prefix that corresponds with the identified number of atoms for the first nonmetal if the number is greater than 1. So since we only have one sulfur, there's only one of them, we don't need to add a prefix. Now, what I mean when I say prefix is these are the prefixes we are going to be using for molecular compounds, right? We talked about the fact that this, the name of this, is carbon dioxide, right? And the name itself can help us figure out exactly how many carbons and how many oxygens there are. Well, there's no prefix for this first one, so carbon we're going to assume is 1. But in the second part, dioxide, there's how many oxygens? 2. Also, this other one, very common, H2O. The name of this compound is dihydrogen monoxide. Okay, well, how many hydrogens are in this compound? There's 2. Look at the prefix. 2 is di. And 1 oxygen, monoxide. Mono means 1. So we are going to be learning how to actually do these. So following this same pattern, how many sulfurs are there? There's 1, but since the first element is 1, I don't have to write mono. I'm just going to write sulfur. Now, since there are two oxygens, I'm going to put the prefix of di in front of oxide because this is 2-sulfur dioxide. There's my compound. Now, I don't have to put mono here, but you're going to see later where we are going to need to add a mono. Okay, here, next one. We have 2 chlorines and we have 8 oxygens. 2 chlorines, 8 oxygens. All right, so what is the prefix for 2? It's di. So I am going to add a prefix here because it's more than one. So this becomes dichlorine. Okay, we keep the ending of the first word the way it appears in the periodic table. But how many oxygens do we have here? We have 8 oxygens, and the prefix for 8 is octa. So I'm going to add oct oxide, or you could write octa oxide, doesn't really matter, because this tells me there's 2 chlorines, there's 8 oxygens, and since it's the second in the compound, I have to drop the ending and add "ide." All right, here, in this one, I have nitrogen and oxygen. How many nitrogens are there? There's 2, and what is the prefix for 2? Right here, it's di. So this is going to be dinitrogen. Okay, you add the prefix, but you keep the ending of the first element the same. And how many oxygens are right here? There's 1. Now, up here, we didn't have to write monosulfur because it was the first one. But since there's 1 oxygen and it is the second element in this set, we have to add the prefix of mono. So it is monoxide. Mono means 1, there's 1 oxygen. So just from the name, dinitrogen, 2 nitrogens, monoxide, oxygen. Last example, we have SF6. How many sulfurs are there? There's 1. Now, since it's the first element in the set and there's only 1 of them, do I have to add mono? No, I don't. That's the only exception that when you don't have to use a prefix for these, is if there's 1 in the first. And then we have 6 fluorines, and the prefix for 6 is hexa. So this becomes sulfur hexafluoride. Now, you only use prefixes for 2 nonmetals. So if there is a metal in a compound, you do not use prefixes, okay? A lot of times we take what we learned before and we throw it completely out the window and start adding prefixes to things that are metals. Metals, I'm going to add this up here. Metals do not get prefixes. If there is a metal, do not add prefixes whatsoever to that compound. You use what we've learned before to help you name. Okay, now going opposite. You're given the name, you have to write the compound. It's really easy. All you have to do is look at the prefixes. You need to write the element symbol for the first nonmetal and, using the prefix, write the correct subscript. Here we have nitrogen. There is no prefix, so we're going to assume that there's 1. Here we have trifluoride. The prefix is tri. Tri means 3. So we have 3 fluorides. So I would write this as NF3. 1 nitrogen, 3 fluorines. Over here we have disulfur dichlorine. How many sulfurs are there? Di is 2. Dichloride, di is 2. So this is S2Cl2. 2 sulfurs, 2 chlorines. Again, down here, dinitrogen, di is 2. Tetroxide, tetra is the prefix, and tetra is right here. Tetra is 4. So nitrogen, I have 2. Oxide, oxygen, I have 4. And the last example, we have oxygen dibromide. Oxygen, there's no prefix, so that means there's 1. Dibromide, bromine, di, that means there's 2. So my formula here is OBr2. Now, notice every single one of these compounds here are 2 nonmetals together, okay? I cannot emphasize enough. You only use prefixes when there are 2 nonmetals together. You do not use prefixes for metals and nonmetals. Do not. If you have positives and negatives together, you do not use prefixes, okay? So when you are putting positives and negatives, cations and anions together, no prefixes. okay? Prefixes only apply when there are two nonmetals together.